Andres, shush. Okay, here we go. Today, counted loops. So counted loops, I'm going to leave myself a little note here. Counted loops in C++. They're a way to get the computer to count or do a task more than once. So for instance, let's say I say to you, write the word hello on the screen 5 times. So you would dutifully come over here, type that out. Let me unfreeze my screen. Okay. And you could copy and paste that 5 times if you wanted. And there you go. You've got hello on the screen 5 times. Good. Let's say I say do it 20 times. Well, then you could go like this and write 20 lines of code, which would be super inefficient, by the way. There's 20 lines of code. And that will write hello 20 times. Okay? Now, there's a trick in C++ to get it to do it with just 1 line of code. So I don't really ever want to do something. If I'm going to do something 20 times, I certainly don't want to write that code 20 times, especially if I'm on a computer that can theoretically count very easily. So if I could write this code in curly brackets, okay, just like an if statement, very similarly, and in front of this curly brackets, just say run 20 times. That's what I got to do, okay? Yeah. Now, the syntax for that is actually you have to write 3 lines of code in this brackets, okay? All separated by semicolons. So the first line you write is you make a variable that starts at, I'm going to start it at 1. Okay, so there's my first line of code. Make a variable, give it a starting point. Second line of code inside that bracket is a condition that I has to meet. So I'm going to write I is less than or equal to 20. So that will run. That means run it as long as I is less than or equal to 20. And so this would probably actually run forever. You also have to write the word. Actually, I'm not going to do that yet. Well, I'm going to write the word for in there because that's the code for the loop. Okay, it's called a for loop. Can you get the door, Will? Okay, so if I run that, it should run forever. No, it doesn't run because it's missing the third. Oh, wait, maybe it will run. Let's see. It runs forever. You can see that I is always less than 20 because I is always equal to 1, right? So it's just stuck there, and I can see it scrolling down over here. It's writing it as fast as it can. So the last thing I need to do is make I go up. So my third line is an increment that says make I go up by 1. Now it will run until I is 21, and it'll stop it there. So it'll start at 1, run it, then it'll go to 2, 3, 4, 5, and it should run it 20 times. There you go. It stopped it. Hopefully, we'll have a look and see if that matches up with what we think it's doing. So the other important thing about the for loop is this variable I. It actually keeps track of where we are in our computation, in our count there. So I gotta just put a little colon in front of that. And you can see it actually kept track of where I was. Okay? Now, let me see if it'll do it 20,000 times. Okay? It will. I just wrote 20,000 lines of code by changing one thing. I can scale it up. Okay, it's pretty slow because it's actually writing on the screen is a slow operation, but if I don't write it on the screen and I just say like, I don't know, just some sort of any line of code here, it'll run it instantly. It can do 200,000 processes in half a second or whatever. Okay? So that's good there. The other thing I wanted to show you today is, so you'll just have some questions on working with this. But one thing I wanted to show you, I'm just going to run it from 1 to 10, is this thing called the debugger in C++. Yo. And what it does is it allows you to stop your code and run through it a line at a time. So I'm going to stop my code right here by putting a little stop sign in there. Okay? Just pick the number you want to stop your code on and put a stop sign. It looks like a little red circle, but it's actually a stop sign. Okay? So my code is going to stop here now if I run it with the red play button. See the red play button up here? It says debug. So this can be useful for us. Okay, let's see what happens. It's always a little bit slower to run, actually. But now there's a yellow cursor that says I am stopped on this line of code. I have not executed it yet. In addition to that, with debugging, it's also important to show all your variables so that you can look at them. So you'll want to click on this little Windows and click Watches. Watches is got a list of all the variables in your code. So if I go down here now, I should be able to see all my variables right here. Right. You'll notice that I is filled with junk right now. Okay. I has a storage location, but whatever was in it was this number, 4,200,555. It's because I have not executed this line yet, but to execute a line, you press F7, or you press this button up here, next line. So I'm going to press F7, and now I'm down to this line here. You can see that I is equal to 1 now. That's great, because that was the line of code that does that. It's going to execute this line. Hopefully it will have written on the screen 1 and the word hello. Check it out. Yes, it has. It's waiting for the next line of code to execute. I is now 1. If I press F7, we should see it climb up to 2. And it's just going to basically cycle through this code until I is greater than 10. Greater than or equal to 10. So I'm going to run it again. It says 3. Says 4, says 5, says 6. This is a really powerful tool later on when you don't really know what your code's doing. Let's say you overcode something and it runs, but it's not doing what you think it's doing. A great way to figure out what's going on is just to step through it a line at a time and see what's happening with your variables. So now it's at 10, and it's still happy at 10 because I is less than or equal to 10. But if I becomes 11, it's going to quit. Just like the if statement. See, now it's done this loop. It no longer wants to run this line of code. It's written the 10 lines on the screen. It's happy to do that, and now my code is officially done. So that is the debugger. Can be very useful. It's not really useful sometimes if you have like a huge 1,000 lines of code and 500 variables or something. Then it could be kind of hard to figure out where your little error is occurring by just stepping through it a line at a time. Especially if you're, let's say you're running a game and it's running 144 frames a second. You're in some sort of loop that's running 144 times a second. It's hard to figure out sometimes where your program is screwing up. It's hard to figure out where to stop it to find out where it's screwing. But that's for another day when we get into graphics. Okay, so that is counted loops today. We got a lab 9 we're going to work on. I'll